We've seen that decision trees form a very interesting data structure for both classification and regression, where we talk about hierarchically, constructively decomposing the solution space into several subspaces by taking a candidate variable for splitting the solution space at each point. So candidate variable at this point is probably different because solution space is different versus say the candidate variable for here is different. So what is the science behind choosing the candidate variable and the value where you're talking about creating the corresponding split? Here we have multiple choices of metrics which can be used to determine the candidate split, and this set of criteria are called splitting criteria. So splitting criteria, there are two broad splitting criteria which are very commonly used, which is basically one is called entropy. The other is called Gini coefficient. Let's look at entropy. Entropy by itself is a universal concept, as we all know from materials and physics concepts. Entropy is a basic idea of how disorderly or orderly a system is. And let's look at it in general in a sample, right? Let us assume that we have a sample of 10 items where we have suppose 8 of them of one type and 2 of them of another type, right? And suppose we have another sample in which we have 5 of them of one type and 5 of them of the other type. Both of them are total of 10. But what is the difference between both of them? So here we're talking about a more uniform distribution of this thing because there's a majority of one type. Whereas here there is more like a more spread out, or what you can say is there's more variety, right? So that is basically inherently what the notion of entropy measures. So entropy is measure of how non-uniform a particular sample is. So in this context, entropy of this, which is more uniform, is lower than the entropy of this. So suppose in the extreme case, we have all of them of say same type. Then we actually call that as entropy of 0. On the other hand, if you have something which is equally divided into two types, this actually has a perfect entropy of 1. So entropy is basically a quantitative measure of non-uniformity or variety in a sample. So if you see here, we talk about measuring entropy by means of a technical formula also, where you say that it is sigma of different categories. Here are the two categories, all the categories minus of probability of that and sigma of pi log pi. So what this does is, this basically captures what the probability of each sample part or variety. If there are two, then you can have probability of first sample, then second probability of second sample, and take sigma of pi. Suppose in case of both being 0.5 and 0.5 of equally divided, this actually translates into 1. Whereas if you talk about one of them having 0 and the other one having all the constituent, it leads to entropy of 0. So entropy varies between 0 and 1, and what happens when you are talking about using entropy as the concept for determining the candidate variable, You look at all the candidate variables with assignment to a particular value and try to compute the corresponding entropies and see how the entropy is playing out when you look at that particular split. And that particular entry will determine which candidate variable value combination gives you the highest change in entropy, or also called as information gain, and that is chosen as the candidate variable here. Suppose you have two variables, x1 and x2, one of them gave 0.5, another one gave 0.6. So the one which is 0.6 will be the candidate choice for splitting, and therefore that is chosen as a candidate. So at any point you probably have multiple choices of candidate combinations for splitting the solution space, but we use the one which gives you the maximum information gain, which is known as the change in entropy. So entropy, as we understood, is a very interesting concept for determining the candidate variable, which is able to give a variety to the solution space by making sure that there is some kind of an equitable distribution of the original data in both branches. So that's the underlying principle by which we use entropy or information gain as the basic candidate choosing mechanism. So what happens when we choose one which has the highest entropy? What it does is it's able to make sure that both branches have reasonably equal or equitable split in terms of number of candidates which are separated from each other. On the other hand, there is one more angle from a machine learning perspective which is very important, which is if you have very low entropy, what happens is there is very high uniformity. There is actually very little statistical significance in such a sample, because what will you do a classification of such a sample? If such a sample is so uniform, there is no point of running a classifier. It actually gives you a point by which you can equally equate it to the majority class rather than saying that there is a classifier which is separating both classes. So there is a need for presence of variety or reasonable non-uniformity in the original sample so that you can run a classifier. Otherwise, determining a classifier becomes a futile job. Just like entropy we looked at in terms of basic probability of each individual category and sigma of minus pi log pi, there is an alternative coefficient which is very similar to entropy, but what it does is sigma of overall categories. It tries to measure the joint probability of something being present or something being misclassified by being present in the other sample. So that is called as a Gini coefficient. It's measured by sigma of I minus pi times 1 minus pi. So alternatively, between entropy and Gini coefficient, you can use any of the candidates as the variables or as the criteria to choose which candidate variable value combination will be chosen for splitting at a particular point. So as you can see, once you break at the next level, again you have a different input space. In that you have to run this again, and the number of candidate variables value combination will be different. In this it will be different. So additionally, you will find that at each parallel node you have very different variable value combinations on both sides, though it is basically coming from the same root node. So it's very important for us to understand that Gini or entropy is basically giving you a metric for which how better you can segregate the data into two separate classes, and it gives a measure of how good the classifier will perform.